Astronomers have speculated for decades that a gigantic world hides in the frigid borders of our solar system, beyond Neptune. According to recent discoveries, Planet 9, a far-off monster almost 5 times the size of Earth, is real and subtly changing our perception of the universe. Its existence is now supported by numerous separate lines of scientific evidence. As sophisticated telescopes get ready to scan the sky, we stand on the verge of verifying one of astronomy's greatest discoveries, from the odd orbits of far-off objects to irregularities in spacecraft trajectories, the enigmatic grouping that began it all. Something that defied astronomical likelihood was observed in 2016 by Caltech astronomers Michael Brown and Constantine Batigan. The orbital properties of six-trans Neptunian objects, TNOs, which are icy items orbiting beyond Neptune in the far-off Kyper belt, were strikingly similar and shouldn't have happened by accident. Before being launched out into the outer solar system, these objects go along long elliptical paths that bring them abnormally close to Neptune. Their orbits are slanted at almost the same 30 degrees angle to the main planetary plane, which is where the majority of solar system objects orbit, which makes the situation even more perplexing. It is estimated that there is a less than 0.0000 chance that this orbital configuration will arise spontaneously without outside interference. The researchers' groundbreaking paper was acknowledged by 0.002%. This is almost unlikely to be coincidental from a statistical perspective. The trend grew more clear as more TNOs were found and categorized. 13 of these objects have the same odd alignment today, all pointing in virtually the same directions toward their perihelions, or closest approaches to the Sun. This directed clustering clearly implies that these items are being arranged by a gravitational shepherd, who is keeping the flock in order like a cosmic sheepdog. The statistical strength of this evidence is what makes it so strong. Other theories, such as observational bias, have been thoroughly examined and disproved. Even after controlling for all potential biases in the way and location of astronomers' telescopes, the clustering is still statistically significant, according to a 2021 study created especially to examine selection effects in TNO data. The first significant hint that prompted astronomers to suggest the presence of Planet 9 was the clustering effect, which is still one of the most compelling pieces of evidence to this day. The statistical case only gets stronger as each year brings new discoveries of farther-off objects. The orbit of the recently discovered asteroid 2015 BP 519 is 54 degrees off plane of the solar system, without the influence of a massive planet, which is exactly where Planet 9 is anticipated to be, an extreme orientation that computer simulations demonstrate is almost impossible. The hidden giant is revealed by computer modeling. Astronomers created increasingly complex computer models of our solar system to see if Planet 9 could account for the observed grouping of TNOs. In just a few days or weeks, scientists may conduct tests spanning billions of years in these virtual cosmic laboratories, comparing several scenarios to determine which one most closely resembles reality. Several simulation scenarios were developed by researchers. There were multiple common models that included a giant planet with different masses and orbits, one that did not include Planet 9, and one that just used the known planets and the galactic tide. The findings were clear-cut and convincing. The TNOs dispersed haphazardly across the Kuiper belt, adhering to the orbits determined by natural forces, since Planet 9 was not included in the simulation. None of the clumping we see in real life was seen on their journeys. However, something extraordinary occurred when scientists included Planet 9, which is around 500 astronomical units from the Sun and has a mass roughly 5 times that of Earth, in the model. The simulated objects immediately grouped themselves into the exact same clustered pattern astronomers observe in the night sky. It was like watching a puzzle solve itself, one of the astronomers who worked on the modeling described. Everything fell into place for us when we included Planet 9 in our simulations. The exact orbital properties of these objects, including their elongation, tilt, and distribution, were replicated by the models in addition to the clustering effect. One by one, The simulations have been successful in ruling out other possible reasons. For example, the hypothesis that similar effects could be produced by the combined gravity of numerous small Kuiper belt objects has been rigorously studied and disproved. An exaggerated distribution and total mass of things would be necessary for such a situation. The existence of a single massive planet is far more likely. These simulations are especially potent because of their ability to predict outcomes. The Planet 9 models forecast where new objects should be discovered in addition to explaining known TNO orbits. With each confirmation, the evidence for Planet 9 gets stronger as scientists find more distant objects that fit these predictions. The spaceship senses its attraction. An unexpected source provides one of the most direct lines of evidence for Planet 9. As the Pioneer and Voyager spacecraft traverse the outer solar system, they are encountering small gravitational anomalies on their courses. These spacecraft have traveled farther from Earth than any other spacecraft we have ever created. There is a slight but enduring gravitational impact that cannot be explained after taking into consideration all known forces that affect these spacecraft, such as the pressure of solar radiation, the gravitational pull of all known planets, and even the minuscule force of interstellar dust. Even though Planet 9 is not yet visible to our telescopes, this enigmatic force essentially enables these spacecraft to sense its presence because it coincides precisely with its expected position. The fact that these spacecraft are leaving our solar system in various directions adds even more weight to this claim. Both, however, pick up on comparable unexplained gravitational effects. This multidirectional confirmation makes it very likely that they are feeling the pull of Planet 9, a gigantic object, from various directions. The Deep Space Network, which can track these spacecraft with amazing precision, makes the influence observable even though it is slight. Just a few meters per year of divergence from their projected trajectories. Initially, NASA engineers thought that these discrepancies were caused by small gas leaks or thermal radiation from the spacecraft's nuclear power sources, but extensive investigation has ruled these theories out. According to a new study published in the Astrophysical Journal, the spacecraft anomalies are real gravitational force measurements rather than merely orbital patterns. They offer a direct scientific observation of the gravitational field precisely where Planet 9 should be according to our models. These gravitational anomalies are now also being watched for by the New Horizon mission, which passed Pluto in 2015 and is currently traveling into interstellar space. It would essentially triangulate the position of Planet 9 if it senses the same pull as the Pioneer and Voyager probes, offering a third independent confirmation from yet another direction in space. In the farthest depths of our solar system sits the enigmatic and remote planet Sedna. Finally, the mystery of Sedna's orbit was revealed. Since its discovery in 2003, the minor planet Sedna has baffled astronomers. Over its 11,400-year orbit, this far-off world travels in an incredibly lengthy orbit, moving from roughly 76 astronomical units to almost 1,000 astronomical units from the Sun. The fundamental question of what caused its peculiar orbit is raised by the fact that Sedna never gets close enough to Neptune to have been gravitationally impacted by it. It was an unsolved mystery for almost 20 years. How Sedna came to follow such a drastic course was beyond the scope of conventional models of solar system development. However, Sedna's strange orbit became entirely logical when astronomers included Planet 9 in their theories. The trajectory we see Sedna pursuing would be naturally produced by the gravitational pull of a planet with the exact mass and orbit predicted for Planet 9. According to International Astronomical Union planetary scientist Dr. Catherine Richardson, Sedna has been the white whale of solar system astronomy. There was just no known mechanism to account for its orbit. This riddle is neatly and fully resolved in Planet 9. The degree to which Planet 9 explains the orbits of other extreme objects, such as 2012 VP13, often known as Batigan, is much more compelling. Despite having comparable orbital features to Sedna, this object was found on its own 10 years later. It is quite likely that Planet 9 is the right explanation because it can simultaneously explain both orbits without making any extra assumptions. More recently, Scientists have found an object known as the Goblin, 2015 TG-387, which has an even more extreme orbit, reaching 2,300 astronomical units from the Sun. Another independent confirmation of its existence is provided by computer models that demonstrate that its orbit stays stable, particularly due to the gravitational pull of Planet 9. One of the most compelling arguments in support of Planet 9 is its capacity to explain these unusual orbits. Over astronomical time periods, these orbits would be unstable in the absence of a huge object in the outer solar system. However, because Planet 9 serves as their gravitational anchor, they continue to exist. The secret tilt of the solar system is revealed, another long-standing solar system conundrum that has baffled scientists for decades is likewise resolved by the existence of Planet 9, the odd tilt of the Sun's axis of rotation with respect to the planet's orbits. The average orbital plane of the 8 known planets is around 6 degrees from the Sun's rotational axis, a tiny but important difference that shouldn't be there in a solar system that is fully constructed. The creation theory of the solar system has been plagued by this misalignment. The central star and its planets should revolve in the same plane in a correctly formed planetary system. However, astronomers have had difficulty explaining why ours doesn't. The gravitational tension required to produce this 6 degrees tilt over the solar system's lifespan would be precisely exerted by a planet with the estimated mass and orbit of Planet 9. According to recent calculations, the Sun's axial tilt naturally arises from the calculations when Planet 9 is included in solar system models. Here's another instance where Planet 9 provides a compelling explanation for an observation that would otherwise go unaccounted for. Astrophysicist Dr. Elizabeth Chen says, "It's amazing that scientists didn't go out to explain the tilt of the Sun using Planet 9. It naturally arose from the simulations as a result of the existence of Planet 9. A strong scientific theory is characterized by this type of surprising explanatory power. Additionally, the timing is ideal. According to the calculations, over the first billion years of the solar system's existence, Planet 9 would have moved to its current, far-off orbit. As the early solar system settled into its ultimate structure, this time frame corresponds to the time when the tilt of the Sun would have been determined. Furthermore, what would otherwise be a strange coincidence is resolved by this explanation. The planet's orbit is tilted exactly the same degree from the Sun's equator and the average orbital plane of the entire solar system, which is known as the ecliptic plane. There is just one mechanism offered by Planet 9 that explains both tilts at once: the journey of Planet 9. Two tales of origin. Not only does Planet 9 exist, but how it got into such a strange and far-off orbit is one of the most fascinating mysteries surrounding it. Astronomers have come up with 2 tenable theories for its origin after doing a lot of simulation. According to the first theory, Planet 9 originated about 4.5 billion years ago, significantly closer to the Sun than Uranus and Neptune. The heavyweight planets probably expelled it outward onto a considerably more distant orbit during the tumultuous early days of the solar system due to gravitational interactions with Jupiter or Saturn. This hypothesis of planet ejection is consistent with our understanding of the chaotic youth of the solar system. According to computer simulations, the early solar system was much denser, with planets vying for space before establishing steady orbits. According to these models, a number of planets the size of Earth or larger might have been expelled entirely from the solar system at this time. Planet 9 remained gravitationally connected to the Sun, although it was only moved to a far-off orbit. According to astronomer Dr. Marcus Wong, the early solar system was basically a gravitational pinball game. The result of this turbulent time is probably what we're witnessing with Planet 9, an outwardly kicked planet that was not entirely expelled. The other possibility is that Planet 9 was abducted from another star and never originated in our solar system. Astronomers are aware that in their early years, stars frequently form in clusters and pass very close to one another. Planet 9's peculiar orbit might have been caused by gravitational capture if it had been orbiting another star that was close to our Sun at first. The reason Planet Nine's orbit differs so much from the other planets' almost circular aligned orbits could be explained by this star capture scenario. Its anticipated orbit analysis reveals features that are in line with what we would anticipate from an exoplanet that has been captured. The likelihood of such a capture happening is relatively high, possibly as high as 10% during the Sun's first 100 million years, according to recent simulations conducted by astronomers at the University of Zurich. This implies that the discovery of a captive planet in our solar system shouldn't come as a surprise. Instead, the absence of at least one would be statistically rare. Both theories are supported by science, and first-hand observation of Planet 9 is necessary to assess its composition and exact orbit in order to determine which is true. The ejection idea is strengthened if its composition is comparable to that of Uranus and Neptune. The possibility of capture increases if it differs from our other planets in composition. Determining the precise location of Planet 9, astronomers now have a far better idea of where Planet 9 might be hidden, thanks to the most recent data and simulations. According to current models, it is roughly 500 times further from the Sun than Earth, orbiting it at an average distance of 500 astronomical units, or AU. Because of its extremely lengthy orbit, it can be as close as 200 astronomical units at perihelion and as far away as nearly 1,100 astronomical units at its furthest point. This enormous orbit contributes to the difficulty of direct detection. Even with our best telescopes, it would appear exceedingly pale from Earth, since it receives so little sunlight at such great distances. Planet 9 only completes a full orbit around the Sun once every 10 to 20 millennia, with an estimated orbital period of 10,000 to 20,000 Earth years. Conventional detection techniques are difficult to use because of this incredibly slow movement across the sky. On the basis of its gravitational effects on TNOs and spacecraft trajectories, astronomers have now significantly reduced the search area. If Planet 9 is near its closest approach to the Sun, it is most likely in the constellation Orion. If it is farther out in its orbit, it is most likely in Taurus. This has made it possible to conduct focused searches using the most potent telescopes on the planet. Dr. Carlos Mendez of the Pan-STARRS Observatory said, "We've moved from looking at the whole sky to concentrating on particular areas where Planet 9 is most likely to be. It seems as though we are now only scouring one bay instead of the entire ocean. The anticipated appearance of Planet 9 complicates the hunt even further. It would only seem to be a tiny dot moving very slowly against the star's background at its estimated size and distance. It may seem as a single pixel of light, even with the biggest telescopes in the world, making it difficult to tell it apart from far-off stars or galaxies. A method known as shift and stack is being used by astronomers to overcome this difficulty. It entails taking several pictures of the same region of the sky over time, digitally shifting them to account for the anticipated motion of Planet 9, and stacking them to reveal objects that are too faint to be seen in a single exposure. The quest gets more intense. Emerging technologies are coming closer. The competition to be the first to observe Planet 9 up close has intensified significantly as the evidence for its existence becomes more and more compelling. Within the next few years, a number of cutting-edge observational technologies are being implemented that should provide a definitive answer to the topic. With its enormous 3.2-gigapixel digital camera and 8.44 primary mirror, the Vera C. Rubin Observatory in Chile, which is almost finished, offers humanity its best opportunity to date of seeing Planet 9. In late 2025, the observatory will start the LSST, or Legacy Survey of Space and Time. This groundbreaking telescope will sweep the whole visible sky every few nights with previously unheard-of sensitivity, detecting objects 100 times fainter than those currently visible. There is a good likelihood that the Rubin Observatory will detect Planet 9 in the first 2 years of operation if it exists, as the data clearly suggests. The Rubin Observatory is more than a small step forward. According to Dr. Mendez, it's a quantum leap in our capacity to identify far-off, faint objects. Rubin will locate Planet 9, if it exists. In addition, The James Webb Space Telescope is joining the quest by utilizing its unparalleled infrared sensitivity to look for the thermal signature of Planet 9 instead of reflected sunlight. Due to the fact that Planet 9 is predicted to be exceedingly cold, possibly as low as -226 degrees Celsius, the majority of its energy would be released in the infrared region, which is where Webb thrives. The Japanese Subaru telescope in Hawaii, which combines remarkable imaging capabilities with a broad field of view, is another intriguing strategy. This instrument is already being used in a systematic study known as the Outer Solar System Origin Study, which is systematically searching the areas where Planet 9 is most likely to be located. The prospect of a specialized space mission created just to locate and investigate Planet 9 is arguably the most thrilling. Concepts for such missions, which would make use of cutting-edge technologies like solar sails to swiftly reach the outer solar system, are already being considered by NASA and other space organizations. Astronomers are certain that direct detection is only a few years away due to the combined strength of these new observational methods and increasingly accurate forecasts regarding the location of Planet 9. The appearance of Planet 9, a picture of a far-off planet. Astronomers have created intricate simulations of what Planet 9 most likely looks like, based on its gravitational effects and our understanding of planetary formation. Current calculations provide a convincing preview, but the final answer will come from first-hand observation. Neptune, an ice giant with a rocky core encircled by a thick covering of water, ammonia, and methane ice, and capped with an atmosphere of hydrogen and helium, is probably more like Planet 9. Its great distance from the Sun and estimated mass of 5 times Earth's make this composition entirely consistent with theories of planetary creation. The surface of Planet 9 would be extremely cold, possibly as low as -226 degrees Celsius or -375 degrees Fahrenheit, given its great distance from the Sun. Because of its cold climate, any methane in the atmosphere would probably condense as snow, making the planet seem pale blue or even white to the naked eye. According to planetary scientist Dr. Jessica Miller, if you were standing on Planet 9, the Sun would not be the prominent disk that we perceive from Earth, but rather a very bright star. Even during the day, stars would be visible in the continuously dark sky. The idea that Planet 9 could have its own moons or ring system is an intriguing one. There is no reason to believe that Planet 9 would be an exception to the rule that the majority of the massive planets in our solar system have vast moon systems. The genesis of the planet may possibly be revealed by these moons. Its moons might be composed differently than everything else in our solar system if it were captured from another star system. The tilt of Planet 9's orbit with respect to the main planetary plane is probably around 30 degrees. It is impacting the clustered TNOs at the same angle. This notable tilt also implies that it was either abducted from somewhere else or expelled from the inner solar system, indicating a tumultuous past. Even if you were somewhat close to Planet 9, it would be extremely difficult to see with the naked eye due to its enormity. It reflects hardly any light at such distances from the Sun. Powerful telescopes alone won't be enough to find it. Advanced image processing methods will also be needed to separate it from nearby stars and galaxies. Consequences for our comprehension of planetary systems. Our knowledge of planetary systems throughout the cosmos would be significantly impacted if Planet 9's existence were confirmed. It would imply that other stars may have similar far-off worlds. Because planets are too far from their stars and reflect too little light, they cannot be identified using the present detection methods. Imagine how many more there are out there around other stars if we have a 9th planet hiding in our own backyard, says astronomer Dr. Michelle Rivers. It might indicate that there are billions of these far-off ice giants in the cosmos that we haven't even noticed yet. Planets that orbit near their star are strongly favored by current exoplanet discovery techniques. The transit method, which detects minute dips in starlight as planets pass in front, or the radial velocity approach, which measures minute wobbles in stars brought on by the gravity of orbiting planets, are the two methods used to find the majority of exoplanets. Detecting planets with tight orbits around their star is heavily favored by both approaches. Planet 9 implies that a whole population of far-off worlds that resemble it is most likely missing from our exoplanet catalogs, possibly the most prevalent kind of planet in the cosmos that has eluded current detection techniques. Astronomers are currently creating new methods, especially for locating far-off exoplanets as a result of this discovery. We would also have to reconsider our understanding of how the solar system formed in light of the discoveries. Planets should form in a disk and stay essentially on the same plane, according to the majority of current theories, which predict that planetary systems should be rather tidy and organized. This perspective is called into question by Planet 9's peculiar orbit, which raises the possibility that planetary systems are significantly more volatile and chaotic than previously believed. The first verified instance of planetary exchange between stars would be provided by Planet 9 if it was actually captured from another star. This would create new opportunities for the migration of planets between other stellar systems, the distribution of possibly habitable worlds, and even the propagation of life throughout the galaxy are significantly impacted by this. For the solar system we live in, rewriting the textbooks would be necessary if Planet 9 were confirmed. The addition of Planet 9 would require us to broaden our perspective on the scope and structure of our solar system, so much as Pluto's reclassification made us reevaluate what makes a planet. This far-off behemoth on its eccentric orbit would have to be added to the conventional idea of 8 planets orbiting the Sun. Finding Planet 9 would serve as a reminder that important discoveries can be made even in our own cosmic neighborhood if we are tenacious enough to search for them. Planet 9 serves as evidence that exploration and discovery are still ongoing, even in ostensibly familiar area, in a time when many people believe that everything around has been discovered. Astronomers are growing more optimistic that the first direct photographs of Planet 9 will soon be available as the Vera Rubin Observatory is ready to start its systematic sweep of the sky in late 2025. Multiple convergent lines of evidence, advanced computer modeling, and new observational equipment all point to the possibility of a historic finding, one that will alter our perception of our position in the universe for all time. Thanks for watching another episode. Please like and subscribe for similar content.